What's going on, everybody? Moving on with our last lesson in chapter 10. We are still doing probability, but now we're going to be talking about two-way tables. Okay, so just to review, remember we talked about theoretical probability. That's what should happen, and we calculate that by doing the number of favorable outcomes over the total number of outcomes. But experimental probability is just the number of successes over a number of trials. So remember that theoretical probability is what should happen before you do it. Experimental probability is what actually happens when you do it. Okay, so going on with just simple basic probability about some things that we may not have been able to cover in 10.1. In a deck of cards, there are 52 total cards. There are two colors. There's 26 red cards and 26 black cards. There are four what we call suits, hearts, diamonds. Those are both red. And there's... Nice, thank you, Bill. There's hearts and diamonds. Those are both red. There's 13 each. There's clubs. There's spades. Those are both black. Those are 13 each. And each suit has 13 cards. 2 through 10, a jack, a queen, a king, and an ace. So 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, that's 9. A jack, queen, king, and ace makes 13. Okay, and then here's just a visual representation of what a deck of cards looks like, right? So half of them are red, half of them are black, a quarter of them are hearts, a quarter of them are diamonds, a quarter clubs, and a quarter spades. Okay, so some examples. What is the theoretical probability of drawing a red card from a deck of cards? So a red card would be, if I wanted to be technical, that would be 26 over 52, but we know that that would simplify to just 1/2. What is the theoretical probability of drawing a 10 from a deck of cards? If you need to, just go back up, right? A 10, there's 4 10s, right? So we could write that as 4 out of 52. I think that can technically be simplified to, if we divide 52 divided by 4, that comes out to 13. So 4 over 52 comes out to 1/13. What is the probability of drawing a black 3 from a deck of cards? There are 2 black 3s, right? 3 of clubs and 3 of spades. So that means that would be 2 out of 52. Or again, if we simplify that fraction, that would be 1 out of 26. Okay, so those are just basic probabilities of a deck of cards. Okay, probability of spinners, right? We already kind of talked about this a little bit in 10.1. But spinners, it's the same thing, right? What is the probability of spinning a 3? Sorry, they changed the toolbar on my recording program here. So it's a little bit different than what I'm used to. Probability of spinning a 3, there is 1 3 out of 1, 2, 3, 4, 5, 6, 7, 8. So that would be 1 out of 8. Probability of spinning an even number, if I change colors, even number, 8 is even, 2 is even, 4, 6, right? So that's 4 out of 8, but that simplifies to 1/2. Probability of spinning a yellow, right? There are 2 out of 8 yellow spaces, but again, simplify, that would go down to 1/4. Okay, now if we're rolling 2 dice, last lesson we talked about 1 dice. Now if we're rolling 2 dice, right, we have to think what numbers will we get if we roll a 1 and a 1, that obviously would be a 2, right? If we roll a 2 and a 1, that would be 3. 3 and 1 would be 4, etc., etc., etc. So that would be a 5, that would be a 6, and that would be a 7. Okay, fun facts, this column would be the same as this row. 1 and 2 makes 3, 1 and 3 makes 4, 1 and 4 makes 5, 1 and 5 makes 6, and 1 and 6 makes 7. Okay, and even more fun facts, what will end up happening is that all of these numbers, you can see the 4 and 4, if we connect the dots, that makes a diagonal. 5 and 5 makes a diagonal, 6, 6 makes a diagonal, and 7, 7 makes a diagonal. All of those will match up, okay? So because 2 plus 2 makes 4. Look, all of the 4s are diagonal, right? 3 and 2 makes 5. 2 and 3 makes 5. All the 5s are diagonal. So again, we don't have to we just find the pattern. We know that those are all going to be 6s. We know that those are all going to be 7s. Okay, 6 and 2 make 8. 5 and 3 make 8. 4 and 4 make 8. So we know that these are all going to be 8s. These are all going to be 9s. These are all going to be 10s. These are going to be 11s. and these are going to be 12s. Okay, so how many total outcomes? When you roll 2 dice, right, you can see there's 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4, 5, 6. 6 times 6 comes out to 36. There are 36 different outcomes you can have when you roll 2 dice. And if you take a look, right, the highest number that you would likely get out of rolling 2 dice would be a 7, because there's 1, 2, 3, 4, 5, 6 different ways you can roll a 7. That would be 6 out of 36, or if we simplified, that would be 1 out of 6. Right? So theoretically, obviously it doesn't happen, but theoretically, if you roll the dice 6 times, you should get a 7 at least once. Okay, what is the probability of rolling a 7? Well, once again, we just said that. Sorry, right? That was 6 out of 36, which simplifies to 1/6. What is the probability of rolling an even number, right? If we were to go back, now I kind of wish I hadn't erased this, right? But even numbers, you would have to go through and count up all the even numbers, right? So 2, that was a 2 here. Oh, I just have to write. That was 2. That's a 3, that's 3, that's 4, that's 5, that's 6, that's 7. This one was 8, 9, 10, 11, 12. And remember, they all go diagonal. So there's 2, there's 1, 2, 3 4s, 5s we don't count. We count the 6s, we count the 8s, we count the 10s, and we count the 12. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, which makes sense. It should be 8. It's 18 out of 36. Sorry for all of the dots. It is 18 out of 36, which we should obviously have just known from the beginning. I had to double check and make sure. It comes out to 1/2, right? There's half even numbers, half odd numbers. What is the probability of rolling a 4 or less? So again, we have to go back. We know that these are 4s, so there's 1, 2, 3 ways you can roll 4, 2 ways you can roll a 3, and 1 way you can roll a 2. So that's 1, 2, 3, 4, 5, 6. Again, that's 6 out of 36. 6 out of 36, which same as 7 simplifies to 1 out of 6. Clear the screen. Okay, which is more likely, when you're talking about what is more or less likely to happen, you just think of what probability is bigger. Is it more likely to flip a coin and get tails, or more likely to roll a tail on a dice? So tails, tails is 1/2. Rolling a dice is 1 out of 6. Rolling a single dice, right? 1/2 is greater and bigger than 1/6, so you're more likely to flip a coin and get tails. Are you more likely to roll a 2 on a dice or roll a 6 on a dice? To roll a 2 is 1 out of 6. To roll a 6 is 1 out of 6. They are the same. You are equally likely to happen, right? That one is not more likely than the other. Are you more likely to draw a queen from a deck of cards or a black card from a deck of cards? Well, queen, there are 4 out of 52. And we know that for black cards, there are 26 out of 52. 26 out of 52 is much bigger than 4 out of 52. So you're much more likely to draw a black card than to draw a queen. Okay, two-way tables help us organize information into 2 different categories. We can know percentages, probabilities of multiple different things. The one thing that you need to make sure that you pay attention to is two-way tables is making sure that you're paying attention to what the question is asking you to actually find. Okay, and that goes along with intersections and unions. An intersection only includes the common information between 2 separate events, right? The symbol is an upside down U. A union includes all information from 2 separate events, and the symbol is a regular U. Okay, but back to two-way tables, right? Determine the information from the two-way table. The boys and girls of a class were surveyed about whether they like to ski or swim. The two-way table shows the results of the survey. How many students are there in the class, right? Well, that's pretty easy. There are 16 boys, 12 girls, 13 people who like to swim, 15 people who like to ski. So that makes there's 28 total people. How many total girls, right? We use this column and we go across. We see that that is 12. How many students like to ski? Now we're going down. Ski is this column. There are 15 people who like to ski. How many boys like to swim? Now you have the boys and the swim, and that meets there. That's going to be 6. How many girls don't like to swim? Now you have girls, and if they don't like to swim, that means they're probably choosing ski, so that comes out to 5. Right? It's just making sure that you know what exactly they're talking about, because there are 6 different numbers out here in this table, right? They can mean a bunch of different things, especially when it starts asking you about probability. These were just simple one number questions. But if we see here, right, probability makes it a lot different. Okay, so first, also, this is more challenging because we are given blanks. Okay, we have to fill in the blanks. Students were asked in middle and high school whether they liked English or math better, complete the two-way table from the given information. So if there's 43 total middle schoolers and 18 of them chose English, that means that all we have to do is do 43 minus 18. That means that there has to be 25 people who like math, because 25 plus 18 has to give you 43. And then we can do the same thing for the high schoolers. If there's 31 total high schoolers, and then 19 of them chose math, we can subtract that and find out that 12 high schoolers liked English, right? And now if we want to find these totals, we add these two together. 25 plus 19 mean that there is a total of 44 math likers. And then if we do 12 plus 18, that means that there's 30 English likers if we go vertical this way. And remember, they all have to add up. 43 plus 31 does in fact give you 74. 44 plus 30, that's a 30. 44 plus 30 also gives you 74. So just another way that you can make sure that you are erasing things. Sorry, not erasing things. My mind is all over the place. Adding things correctly. Now, if we go in a little bit more and talk about probability, right? Probability of middle schoolers liking math better. So it's important. Remember, probability is what we have with desired over total. So with these, again, there's a bunch of different numbers. It's really hard to always know what the total is. So you have to make sure you know what the question is asking for. Probability of middle schoolers liking math better, right? So we're going to take all of the math likers out of just the middle schoolers. So that means our total is going to be 43, because there's 43 total middle schoolers, and 25 out of those 43 liked math better, right? So we know that 43 has to be our total and not 74. Probability of liking English better, right? So it doesn't tell us whether to determine between middle and high schoolers. It just says probability of liking English better. So that means it's going to be total English, which is 30, this one here, out of total students, which is 74. Probability of the high schoolers that were just asked, right? So out of everybody who was asked, how many of them were high schoolers? So that means that would be 31 high schoolers were asked out of 74 people. Okay, so again, with two-way tables, it's really important that you're paying attention to what the question is truly asking you about and what is going to be your totals and things like that. Okay, a math of 35 students were asked if they were members of the chess club or a math club. 16 were in the chess club, 10 were in both, 9 students were in either club. All right, so that means we have to figure out what to put here. Okay, this is going to, if this is chess and not chess, that means this is going to be math and not math, right? We know that there were 35 total students, so that is our big total. 16 were in the chess club, right? So that means the chess club is this column. There's 16 total in the chess club. And then 10 were in both. So that means if math and chess combined, this is going to be 10. And 9 students were in either club. So not math, not chess, that has to be 9. That means that if there's 16 people total in the chess club, that means that this column would be 16 minus 10, which would give this one to 6, which means that that one would then go in to be 15, right? If that's 35 and 16, we can find out that calculation there. So 35 minus 16 would give us 19 there. If there's 19 here, we can subtract 9 to give us 10 there, right? Which means 10 and 10 would be 20. And again, just double check, make sure everything matches. 10 plus 6 does give you 16. 10 plus 9 does give you 19. 10 plus 10 does give you 20. 6 plus 9 does give you 15. 20 plus 15 does give you 35. And 16 plus 19 does, in fact, also give you 35. Okay, so we can use our deductive reasoning to figure out where those places are, right? And now we can find out what's the probability that you're in the math club. Well, there were 20 people in the math club out of the 35 total students. Okay, that's how we would do that. And that looks like that's it. Okay, bring lots of questions with you. Have a great day. Go Mustangs.